welcome. Let's try to solve Leetcode problem 101, symmetric tree. So this is similar to same tree, but it is only for symmetric tree. So what does that mean? So for the symmetric tree, we are just giving one tree, so as we can see from the root, and we just need to check if they are symmetric. So for the first node, it is the root node. It is okay. It is just one. So we will think it is symmetric. So for the second one, left side and the right side, it is 2 and 2. It is symmetric. We just need to check if the left subtree and the right subtree, if they are symmetric or not. So this is a 3, and here is a 3. It means they are symmetric. This is 4 at the root node for this 2. It's at the right side, but for this 4, it is at the left side, and they also have the same value. As we can see exactly, it is symmetric for this line. Yeah. So this is going to be a true. And for the second case, if we draw a line, for the second case, it didn't work because it is not symmetric. If we draw a line, 1 is okay. For this 2 is okay, but for this 3, it should be there at the left side, but it is at the right side. It means it is not okay. It is not symmetric. So if we understand what is the symmetric tree, so we need to know how to solve it easily. So the easiest way to solve it is by using the recursive function. We just need to run the recursive function to check if this root is symmetric, right? If the left subtree and the right subtree, if they are symmetric or not. We just need to recursively check all the cases. After this 2 is okay, we still need to check at the left side of 2, at the right side of 3. And for this 2, at the right side of this 2, and for this 4, at the left side of this 2. Yeah. So this is how we're gonna check. So this means we're gonna define a function. We're gonna define a function helper function to check, because definitely it is not just using one node. We need to use 2 nodes. So we're gonna check root dot left and root dot right. Because definitely for the root, it is already symmetric. We just need to check the left subtree and the right subtree if they are symmetric or not. If they are symmetric, it means it's going to be a true. Yeah. Now we need to define this helper function. So I'm going to define a private method. It's going to be a boolean and a helper, and inside it's going to be 2 nodes. So it's going to be the tree node P and the tree node Q. Now, what are we going to do? We're going to check which case is going to be true. So currently, we are just checking the left subtree and the right subtree, right? Because those are just the root node. For the left subtree, it is P. For the right subtree, it is Q. So the first condition is that we're going to check if P and Q are exist or not. If they are not exist, so it's going to be true. So if P not exist and Q not exist, so we're going to return a true. In this case, maybe we only have the root node. We don't have the left subtree and we don't have the right subtree, so it's going to be true. Yeah. So another case is that if P not exist, but Q exists, so we are sure it's going to be a false. So this means from the left side it exists maybe like this, but from the right side there is nothing. So definitely it's going to be a false. And similarly, we're going to copy the code to check another case. Normally for the tree problem, we can always do the symmetric compare. If P not equal to none and Q equal to none, so definitely it's going to be a false. This means from the right side, but the same idea. P equal to none, it means from this side it is none. Q equal to none, from the right side it is none. Yeah. So in either case, we're gonna return a false. So otherwise, we need to check the value. So the P dot value gonna equal to Q dot value. Yeah. So similarly, this is similarly for we are checking the same tree. So first of all, this 2 and this 2 gonna be the same. We just need to check if it has the same value. even though they have the same value, but we still need to call the helper function. But here gonna be different. So here p.left need to compare with q.right. Yeah, and similarly we're gonna call the helper function. So p.right gonna compare with q.left. Yeah. Now let me just run it to check if it works. Now as you can see it works, and now let me just submit it. As you can see, it passes for testing cases, and it's pretty fast, and the time complexity is ON, and it's the number of the node. I think that's all about it. Thanks for watching, see you next time.